So we're trying to define types of chemical reactions, and the first kind is a synthesis. You combine one chemical with another chemical. Generically, we said it this way. We said in a synthesis reaction, Hayden, A plus B becomes AB. Hey, sodium and chloride becomes sodium chloride. The second type of reaction was the opposite of synthesis. It was called a decomposition. That's when you break apart a compound. AB becomes A plus B. And you're going to eventually start memorizing these patterns, and you'll learn to spot them in a chemical formula. And that's what we're going to be spending most of the rest of today working on. For example, we have sodium chloride becoming sodium and chloride. And then we balanced it. The third type that we looked at is called a single replacement. And that's where a single element and a compound, the single element bumps one element out of the compound. A metal will bump a metal, a non-metal will bump a non-metal. So for example, we had aluminum and copper chloride. You want the pink sheet out if you have it as well? You're going to need it today. And we said aluminum, which is a metal, can bump copper, which is a metal. And so you can get aluminum chloride, we did the crisscross rule, and copper, and then we balanced it. We left off right here on double replacement. So if you'd be so kind as to turn to double replacement. Okay. You there? You good? Hurry up, get it. In a double replacement, we have two ionic solutions, liquids, and they react. So you pour one liquid into another liquid. You stir it, you shake it, you wait, and you get two ionic compounds. You know what? You get two other ionic compounds. You start with two ionic compounds, Jessica. You mix them up, and what happens is in the first compound, which is made up of two elements, and the second compound, which is made up of two elements, two of the elements trade places. That's why we call it a double replacement. And you can tell it's going on because one forms a, here's your new word of the day, precipitate, a solid. Question?
I don't have my binder.
You don't have your binder here. Is it here?
I don't know.
Is it in?
Locker.
Quick like a bunny.
Yeah.
A precipitate is what you get. A precipitate is what you get when you pour one solution into another solution. You shake, you stir, you wait, and all of a sudden you find something solid clumping on the bottom. As a generic equation, Emily, it looks like this. AB. What does AQ stand for? Do you guys remember? We've used this aqueous in water plus CD in water. You mix them up. Hey, can you see what the double replacement was? Which two things traded places?
B and C.
Pardon me?
The B and C.
Well, the D, the non-metal, joined the metal from A, and the metal, C, joined the non-metal from A. It's a double replacement. Here's an example. PbNO3. Okay, what's Pb? What do we call this? Lead. What's NO3? That's on the back of your pink sheet. Okay, lead nitrate, metal, non-metal, bonded ionically, plus Na, sodium iodide, metal, non-metal. If you mix those together, how will they combine? We can now predict the result. We can say that this guy will trade with that guy. It's a double replacement. The non-metals will switch places. Or the metals will switch places. I find it easier to rewrite the metals and just swap the non-metals. In other words, I'm pretty sure that it's going to be a lead, a sodium, we're going to have an iodine here, but I need to crisscross. What's the charge from your pink sheet on lead? 2. What's the charge on iodine? So if I crisscross off in the margin, I'll have lead, iodine, a 2, a 1, crisscross. You know what? It's going to be lead, PB, I2. And with Na, I'm going to have NO3. They're going to switch places. They're going to switch places. What's the charge on Na? 1. What's the charge on NO3? -1. Oh, that crisscross works nice then. Okay. Is that balanced? No? Let's see if we can balance this. If we're lucky, maybe we can. We're going to pause. So let's see if we can balance this. We're using the notes from last day. You want to find them, Brennan? How many leads on the left? 1. How many on the right? Now you'll notice now I'm going one step further lower. I'm not writing out all the steps. We're going to see maybe if we can try doing these in our heads. You know what? On a test, I'd write out everything, but we're, pressed for time. Let's see if we can do this. In fact, what's not balanced? Is there one compound, one element that you can see right now is not balanced on the left side and right side? Yeah. I have no idea what you said. NO3. So how many NO3s do I have on the left? How many do I have on the right? So maybe put a, in red so it stands out, maybe put a 2 right there. Okay. How will that change things? Well, how many sodiums do I have on the left-hand side now? How many do I have on the right? Sorry, yes, I said that backwards. So let's put a 2 there. Are we balanced? I think we're balanced now. Let's double check. Ready, Justine? Here we go. How many leads, right? How many PBs? 1. How many PBs? 1. Woo! How many NO3s? How many NO3s? Woohoo! How many NAs? How many NAs? Woohoo! How many I's? How many I's?
2.
Whoa. Woohoo! Yeah, here we go. Okay. How can I recognize this is a double replacement reaction? 2 things, metal, non-metal. 2 things, metal, non-metal. A double replacement reaction, you got 4 things, 2 of which are swapping. So let's see if we can predict the next one. Na and OH, sodium hydroxide, I think, plus iron chloride. Let's, Jessica, rewrite the Na. Actually, let's leave some room in front of it to put a coefficient. Let's rewrite the Na. Let's rewrite the iron. And then let's swap the nonmetals. This is a double replacement. The OH is going to end up over here. And the Cl is going to end up over here. But before we balance this, Brendan, we need to crisscross. Let's double check for NaCl. You know what? I think I've seen that one. NaCl is a legal compound. That's salt. Let's double check the FeOH. What's the charge on iron? It's multivalent. What's the most common one? 3. What's the charge on hydroxide? That's from the back, -1. So when I crisscross, I need 3 of those. Is that right? Okay. Hey, let's see if we can balance this one without showing work. Would I do it this way on a test? Nah. Oh, maybe if it was a nice clean one. Everyone's staring out my left. Someone else coming in here? More late humans? I don't know what's going on, but I've had 12 kids late today. Okay. We're finishing the notes off from last day. Hayden, my friend, look up, kiddo. How many NAs? Psst.
1.
How many NAs?
1.
Are we balanced there? Say yes.
Yeah.
Woohoo! How many OHs?
1.
How many OHs?
3.
Are we balanced?
No.
How can we fix that? You know what? Let's put a 3 right there. Because that gives us 3 OHs. Oh, but how many NAs does that give us over here now?
3.
How many NAs?
1.
Let's fix that. How? Yep. Oh, how many CLs now?
3.
How many CLs on this side? Ooh, I like that. Which one haven't we double checked yet?
E.
Which is iron. How many FEs? How many FEs? Sit up straight with some intellectual pride, my friend. You just balanced an equation. By the way, what is the number that's in front right here? It's invisible.
1.
Yeah, 1 and 1. So you can't say, oh, can I reduce the 3s because everything 3 goes into there? There's still some 1s sitting there. Yeah, it's worth a high five. Double replacement. Yep. So you came late and you didn't bring the right binder? Hustle. The next type is neutralization. Acid-base. Now, we did this last chapter, but some of us still struggled with this a bit, so let's go over it. This is when you add an acid and a base. When you add an acid and a base, as I go to my notes for some help, do you remember the products? You get a salt, and instead of writing water, can I write H2O? We all know that's water, yes? So let's try one. It says H2SO4 plus CaO. First of all, which one of those is an acid? Which one of those is a base? And how can you tell? Good review from last test, and we did good on this last test. Yeah. First one's hydrogen. Yep. So here's my acid. In fact, this is sulfuric acid. This is what they use in car batteries. Burns. Bases have an OH on the end, a hydroxide. I know one of the products, Hannah, one of the products is going to be H2O. What else? Well, this and this are going to combine, the metal and the SO4. So it's going to be CaSO4. Oh, we got a crisscross. Are they both 2? Ca and SO4 are 2 and 2, so it'd be a 2 there and a 2 there, which would reduce to 1 and 1, and they balance? Oh, great. I'll still put a bracket there. Whoever's phone that was is going to make sure there's no volume there, or they're going to owe us Timbits. I won't look in the back corner or in the back section over there, whoever's going to fix that quietly. Ready? Oscar, let's balance. Here we go. Oscar, my friend. How many CAs on this side?
1.
How many CAs on this side? Good. How many SO4s? 1, 1. You know what? I think the issue is going to be the H's and the O's. How many H's on this side? Well, there's 2 and 2 more. How many? 4. How many here?
2.
Are you suggesting I do that? Okay. How many? Oh, I'm not going to use this oxygen here because I counted that SO4 as one molecule, one weird-looking atom. So I just need to worry about this oxygen. How many? How many? Woo! We're balanced. Oh, sorry, from you. Woohoo! You are allowed to do that on a test, by the way. Woohoo! Okay. Psst. I don't know. Wonder what? I don't know. I don't think you are either. Last one. Combustion. Combustion. What does the word combustion mean in science? Not quite blow up. Burn. Sometimes explode, but burn. Okay? This is when you have a hydrocarbon. How could you recognize a hydrocarbon? What did a hydrocarbon have in it?
Hydrogen, carbon.
hydrogen and carbon, plus oxygen. Make sure, Hayden, it's O2. And when you do that, this is a source of much of our issues right now in the news. You get two products. You get, what is CO2 in English? Carbon dioxide. What is H2O in English? Or dihydrogen monoxide if you really want to be fussy. But yeah, we call it water. Water, good. Carbon dioxide, greenhouse gas. That's why we're having some issues. So here, you always get the same products. The hard part is recognizing the hydrocarbon and balancing the equation. The hydrocarbon will often look something like this: a C with a number, an H with a number. Sometimes an oxygen will be attached to it with a number because alcohol also burns, and alcohol had a C and an O and an H in it. Plus oxygen gives you always carbon dioxide and water. I know the product. It's going to be the balancing with all the H's and the O's, the oxygens and the hydrogens. That's tricky. Oh, and the third thing you get, I didn't mention, heat, which is why we use hydrocarbons. That's why we use combustion. So let's try this one. CH4 plus O2. How can I recognize what this is? Well, I got O2. I'm combining it with oxygen. And Sarah, my love, it's a hydrocarbon. How do I know? Hydrogen and carbon. Okay? This is a combustion reaction. This is what happens when you light methane on fire. What do you get? I know I get carbon dioxide and water. I can fill that in almost without thinking. But I got to balance. You ready? Sarah, you good? Here we go. How many carbons on the left-hand side? Careful. Is that 4 on the C or on the H? 1. Nice. How many carbons on the right-hand side? Oh, we're done. No, we got to check the rest. How many H's on the left-hand side? 4. How many on the right? How can 1? 2. How can I fix that? Put a 2 in front, not add time, but yeah, put a 2 in front. Okay. How many oxygens on the left? 2. How many on the right? 2 plus 2. How many grand total? 4. I got 4 on the right. I got 2 on the left. How can I fix that? This is also why in a fire people can suffocate, because the oxygen that you need to breathe is getting used in the combustion reaction. And the results are water, which you can't breathe, and carbon dioxide, which you can't breathe. This is why you can get carbon dioxide poisoning if you're in an enclosed room where there's a fire. This is also going on inside of you. This is why you guys breathe out carbon dioxide and water. And if you don't believe me, blow your breath onto a window on a cold day. You'll see the water condense. I wrote down here, you need to know this table from page 265. This is the summary of everything. In fact, have patience. I just gave you this handout. Quiet, please. You with me? You back? Here we go. Let's fill this in together. So, shh. The first type of reaction is the synthesis. And what you want to be familiar with is the general form. So a synthesis, if you want to, you can look at your notes for some help. This is when you were combining two elements. It looks like this. A plus B gives AB. You want a great example? H2 plus O2 becomes, when you combine hydrogen and oxygen, what do you get? What's the chemical formula? This is nice. We don't need to crisscross. We have this one memorized. H2O. Are we balanced? How many hydrogens on the left? 2. How many on the right? Woohoo! How many oxygens on the left? How many oxygens on the right? 1. 2. Oh, how many hydrogens now do I have on the right? Now we're balanced. Now we're balanced. Come grab this, kiddo. How can you recognize this? 2 single elements. That's how you spot it. The second kind is a decomposition. It's the opposite of synthesis. So if you know one, you know the other in terms of what the formula is. Curtis, you just have to remember the words. What's the opposite? Oh, start with A, B, decompose them. Curtis, what do you think they decompose into? A plus B. Hey, you want a good example of that? If you take water and you run an electric current through it, like in a fuel cell, you'll get hydrogen and oxygen. And then if you burn the hydrogen, this is probably going to be in the next 15 years one of the main technologies. You run cars off of it, and the only product is water. Is this balanced? No. In fact, I'm pretty sure we can balance it by putting a 2 there and a 2 there. What do you look for? One compound becomes 2 elements. It decomposes. And I think you guys have seen enough horror movies or zombie movies to know what the word decompose means, to break apart. The next two kind of go together, single replacement and double replacement. They're very similar. In a single replacement, you have a couple and a loner. The couple decides it's not working out. The loner says, well, I'm alone. And they start going out. So it can be something like this. It can be CB plus A. If A and C are metals, it's metals bump metals, non-metals bump non-metals. As an example, well, the one that we gave was sodium iodide plus plus fluorine became. What's going to swap? Let's see. The key to figuring out what's going to happen is this one here. Metal or non-metal? Non-metal, it's going to bump the non-metal. So is it going to bump the Na or the I? It's going to bump the I, and it's going to become NaF plus I2. And then we need to balance it. Let's see. 2 Fs, 2 of those. So I need 2 of those. And, oh, I think it's done. Woohoo! How do you spot this one? Look for the loner. Sort of like the third wheel on a date. Third person coming along and Double replacement. I don't know why the screen's flickering like that. I'll play around with it in a second, but ignore it. My bulb is probably nearly dead. Let's try this, Mr. Dewick. Nope. Sorry about that. Double replacement. Two couples. They both break up, and then they get together on the rebound with the other person. So it's going to be metal, metal, non-metal, non-metal. As our example, we did lead. What did we do? Lead nitrate or nitrite. I can remember which that one that was. Plus Ki. Can you wait for about 5 more minutes? We're nearly done. Metal. Non-metal. Metal. Non-metal. Double replacement. It's going to be lead is going to go with the I, and potassium is going to go with the NO3, but we got to crisscross. What's the charge on lead? Sorry? 2. What's the charge on I? So it's going to be PbI2. What's the charge on K, potassium? 1. What's the charge on NO3 on nitrate or nitrite, whichever one that is? NO3 is nitrate. 1. Oh, that one is crisscrossed already. Is it balanced? Let's see. How many leads? 1. How many leads? 1. How many NO3s? 1. How many NO3s? 1. How many Ks? 1. How many Ks? 1. How many Is? 1. How many Is? 2. Dope! So I guess I need to put a 2 there, which means I need to put a 2 there, which means I need to put a 2 there. Hang on, I got 4. Where do I have 4? Can I move it over a bit like that? Dope. I'm losing a bunch of stuff here, Mr. Dewick. Let's go like this. Undo, undo. It's not quite what I wanted, Mr. Dewick. Come back here. Undo. You really going to do that? Let's do this, this. Click. Arg. Okay, let's try this again, Mr. Dewick. Carefully erasing. Carefully erasing. Which way? Left or right or up or down? Like that? That's what I asked. Okay. Let's try this again and let's balance this again. So let's see. We need... I got 2 iodines. I need to put a 2 there. Is that what we're saying? And that means I now have 2 potassiums. I need to put a 2 there. Is that right? And that means now I have 2 of those NO3s, so I need to put a 2 there. Is that right? And I'm wondering if that NO3 is balanced properly. NO3 was... Oh.
This is a lockdown drill.
Okay, let's finish this off. We had a little interruption there. How can you recognize a double replacement? Did we balance this? I don't know if we did. I'm not going to worry about it. How can you recognize a double replacement reaction? So you want to look for 2 pairs, and it's metal, non-metal, plus metal, non-metal. Mn plus Mn. And they swap. Okay. The next type is what we called, Kenzie, can you go back to where you normally sit, please? Now. Now. Neutralization acid-base. So how do you recognize a neutralization acid-base? We have an acid plus a base. I like the way the chart in the notes puts it. It says look for a hydrogen, and then you have the second part of the acid, plus, then you have a metal and the OH, and you're going to get the metal and the second part of the acid and water. I'm not going to do an example of one, and in terms of recognizing a neutralization, acid starts with hydrogen, base ends with OH. Okay. The very last one is a combustion. Here's where you have some kind of a carbon compound plus oxygen, and this was the one that we know the product. It's going to be carbon dioxide and water. How do you spot this one? Something plus O2, and you get CO2 plus H2O. So we're going to practice a few of these. It wants us to classify this as a synthesis. What would be a good letter to use for synthesis? S. What would be a good letter to use for decomposition? D. Single replacement, SR. Double replacement, DR. Neutralization or combustion. And then it's going to want us to balance. We'll practice the balancing after, but let's see if we can just identify these. So take a look at number 1. What kind of a reaction do you think that could possibly be from the 6 that we've learned? Synthesis, absolutely. You got something plus something combines. So let's put a great big S right there. What about question number 2? What kind of a reaction can the second one be? Yeah.
Combustion.
Sorry? Combustion, the second one? Decomposition. Two things break apart. One thing breaks apart into two things. Right? It's tough for me to explain how you can spot these, Dylan, but all I can do is practice this a bit with you. Third one. Why do you think that's combustion? Convince me. What's your product, first of all? What's the product? What do you get at the end on the other side? And? Okay, you get carbon dioxide and H2O. And what's the reactants? Oxygen and a carbon. So that's how you can spot that. I totally agree with you. This is going to be a combustion. It's going to be a combustion. Okay, what do we think the fourth one is? Single replacement. How do you know? 2 and 1 still become 2 and 1, but 1 traded places. Oh, 1 traded places? What's another word for 1? Single. What's another word for traded places? Replacement. So single replacement, we'll call that an SR. Okay? You folks kind of getting the hang of how we're doing this? Let's jump down a ways. How about number 10? Convince me. Is it 2 things plus 2 things in the on the left-hand side in my reactants? Yeah? Is the product 2 things plus 2 things? In my reactants, is it metal, non-metal plus metal, non-metal? Is my product metal, non-metal plus metal, non-metal? Yeah. Then they're going to swap. This is a double replacement. Okay. So that sheet there, it's lots. I did attach the answers. So what your goal is to see if you can finish this and balance the equations. That's lots of work, I know. If you finish that, I gave you a second sheet. We're going to spend some time working on it next class, but if you want to get a head start, the second sheet I gave you is, did I give you types of chemical reactions? This one?
Yeah.
Word equations?
Predicting the product.
So I didn't give you that one. I gave you predicting the products, this one here. Okay? So again, same idea. Predict the products this time, though. Classify, and then try writing a balanced equation. The really tough part is the word equations, and I know those are just tough. There's no easy way around it. See if you can try those. I'm not going to give you a bunch of these on your test. I did include the answers. So your homework, though, for sure, you want to see if you can finish this one here called Classifying Chemical Reactions. Lots of practice in identifying, lots of practice in balancing. If you get stuck, I attach the answers, see if you can figure it out. I don't think there's any mistakes in the answer key, although there might be because I was using the workbook and there's been some typos before. Okay?